Have you ever wondered why a certain song can make you feel happy or sad for no real reason? Or why the smell of something baking can instantly transport you back to childhood? Well, what if I told you there's a powerful psychological process working behind the scenes, shaping your reactions, your fears, and even your desires, and a lot of the time, you don't even notice it happening? It's called classical conditioning, and believe it or not, the whole thing was discovered completely by accident.
So let's just dive right in with a question. Does the name Ivan Pavlov ring a bell? Yeah, I know. That's the first and last pun, I promise. But it really is the perfect way to kick things off, because this guy, Ivan Pavlov, and his bells are the absolute heart of this whole story.
You see, the funny thing is, Pavlov wasn't even a psychologist. He was a Russian physiologist, a really brilliant one, who actually won a Nobel Prize for his research on doggy digestion. Seriously, he had zero intention of upending psychology. He was just really interested in what makes dogs drool.
So his whole setup was, pretty straightforward for a lab back then. He'd put some food in front of a dog and measure how much it salivated. That's it. It was supposed to be pure biology. A simple stimulus, food, leading to a simple reflex, drool. Or at least that's what he thought. But then something weird started happening. The dogs, they started drooling before the food was even in the room. They'd salivate just at the sight of the empty food bowl, or when they heard the footsteps of the lab assistants coming down the hall. Now think about it. Footsteps aren't food. An empty bowl isn't food. Yet these dogs were having a physical, digestive response.
Pavlov was absolutely fascinated. He called these strange reactions psychic secretions because it was almost like the dogs' minds were creating saliva out of thin air. And that one little observation, that tiny accident, it changed everything. He completely shifted his focus from stomachs to brains and kicked off one of the most famous experiments in the history of psychology.
Okay, so how does this whole thing actually work? How does a dog's brain connect footsteps to food? This is where we get into the nuts and bolts of it all. And you'll see it's actually a surprisingly simple process that happens in 3 basic stages.
So to really get it, we're going to look at this in 3 parts. First, what things are like before any of this learning happens. Then, we'll look at what happens during the conditioning process itself. And finally, the result, what things look like after that new connection in the brain has been made.
All right, so stage 1, before conditioning. You start with something called an unconditioned stimulus, or UCS for short. Now, unconditioned is just a fancy word for unlearned or natural. This is something that automatically triggers a reflex. For Pavlov's dogs, the UCS is the food. You don't have to teach a dog to want food, right? It's just built in.
And that unconditioned stimulus causes an unconditioned response, or UCR. Again, it's unlearned, it's a natural reflex. The dog sees or smells the food, and it salivates. It's automatic. Food in, saliva out. Pure and simple biology.
Now, at the same time, you have a neutral stimulus, the NS. This is just some random thing in the environment that, at first, means absolutely nothing to the dog. In the classic experiment, this was the sound of a bell. Just a noise. It doesn't make the dog hungry, it doesn't make it drool, it's totally irrelevant.
Okay, stage 2. This is where the magic happens. During conditioning, Pavlov would repeatedly pair these things together. He'd ring the bell, our neutral stimulus, and then, right after, he'd present the food, the unconditioned stimulus. Bell, then food. Bell, then food. Over and over and over. And with each repetition, the dog's brain starts to build a bridge, linking the sound of that bell with the delicious food that's coming.
And that leads us to stage 3 after conditioning. A real transformation has happened here. The bell isn't neutral anymore. It's become a conditioned stimulus, or CS. And condition just means learned. Because the dog's brain now associates the bell with food, that sound has gained a brand new power. It can now trigger a response all on its own.
And that new learned behavior is called the conditioned response, or CR. So now the dog hears the bell, and it starts to salivate, even if there's no food anywhere in sight. The bell has become a signal, a predictor, that food is on the way, and the dog's body reacts just in anticipation. And that, my friends, is classical conditioning in a nutshell.
But here's where it gets really interesting. Because this is so much bigger than just dogs and drool. This exact same process is a fundamental part of how we humans learn. It's constantly shaping our emotions, our fears, our desires, often in ways we don't even see.
So this American psychologist named John B. Watson, he basically took Pavlov's ideas and just ran with them. He was a founder of a new way of thinking called behaviorism. And he made this incredibly bold claim that this simple learning process could explain literally everything about us, from how we talk to what we love and what we fear.
I mean, just listen to this famous and pretty controversial quote from him. He truly believed that our environment and all the associations we learn from it were so powerful that they could completely override genetics, personality, you name it. He was basically arguing that nurture isn't just part of the equation, it's the whole shebang.
And to prove his point, Watson conducted the now infamous Little Albert experiment. It's pretty unsettling. He took a 9-month-old baby who initially loved a little white rat, and then, every single time the baby reached for the rat, Watson would sneak up behind him and slam a steel bar with a hammer, creating this horrible, loud, terrifying noise. And pretty soon, just the sight of the rat alone was enough to make little Albert cry in terror.
And that very same mechanism is happening all around us, all the time. It's how phobias are born. It's why you can't even think about tequila after that one bad night in college. It's what triggers cravings for an addict. It's used constantly in advertising to make you associate a product with happy feelings. And on a lighter note, it's even why stingrays in the Cayman Islands have learned that the sound of a boat engine means tourists with food are on the way.
But wait, the learning gets even more specific. On the one hand, you have something called stimulus generalization. So little Albert didn't just become afraid of the white rat. His fear spread to a rabbit, a dog, even a Santa Claus mask. His brain generalized the fear to other fuzzy white things. But on the other hand, you have stimulus discrimination. Your cat, for example, learns that the very specific sound of the electric can opener means food, but the kind of similar sound of the blender definitely does not. It learns to tell the difference.
And you know what? These learned responses don't always last forever. Think of it like this. First comes acquisition. That's when you first learn the association. You hear the ice cream truck jingle. Your mouth waters. Simple. But then, let's say the truck comes by every day for a month, but it's always sold out. Eventually, the jingle stops making your mouth water. That's extinction. The association gets weaker. But then, after a long winter, you hear that jingle for the first time in months, and boom, your mouth waters again. That's called spontaneous recovery. The old response just pops back up after a break. So, okay, we've talked a lot about dogs and babies and ice cream trucks, but the real story here, the reason this matters, is you. These aren't just some dusty old theories from a textbook. These invisible learning processes are happening inside your brain right now, all day, every day. The big takeaway is this: your brain is an association machine. It never stops. It's constantly trying to predict what's coming next by linking things together. That little jolt of anticipation you get when your phone dings with a notification, that's classical conditioning. The way a specific perfume can suddenly make you think of a person you haven't seen in years, that's classical conditioning too.
And that leaves us with one last question to chew on. Think about a strong automatic reaction you have. Maybe it's a feeling of anxiety in a certain place, or a sudden burst of happiness when you hear a particular sound. Now ask yourself, what's the bell? What seemingly neutral trigger in your life has been quietly conditioned to pull your strings?